Hello everyone. So in this video, let's discuss problem 2 of biweekly contest 149. So the question name is reschedule meetings for the maximum free time. Let's first read the question and we'll write the solution, and after that we'll go through the code to understand it perfectly. So yeah. So you are given an integer event time denoting the duration of an event where the event occurs from time t equals to 0 to time t equals to event time. So there is some event happening from 0 to event time. You are also given two integer arrays start time, end time, each of length n. These represent the start and end time of n non-overlapping meetings, where ith meeting occurs during the time start and end time. So in this event from 0 to event time, there are some end meetings happening. So that is denoted from two arrays start and end times. You can reschedule at most k meetings by moving their start time while maintaining the same duration to maximize the longest contiguous period of time free time during the event. So out of these n meetings, we are allowed to move at most k meetings, right? We should not overlap it, and we should move in such a way that we get the maximum free time between any two meetings. The relative order of all the meetings should stay the same, and they should remain overlapping. So this line is very important. So first, the order should be same, and there should be none overlapping. Return the maximum amount of free time possible after rearranging the meetings. Note that the meetings cannot be rescheduled to the time outside the event. Okay, obviously. Let's see the first example. So we have event time 5k equals to 1. So there is an event from 0 to 5 and we are allowed to move 1 meetings. Start time 1, 3 to 5. So there is a meeting from 1 to 2 and 3 to 5. Yeah. So here, if you see, we can move one of these two blocks. Suppose we move this block. If we move this block, so we can move left only. So it will start from 2 and end at 4. So maximum free time we'll have is 0, 1 and 4, 5. So either this block or this block. So it would be 1. But we can get more than one also. Like if we move this block, green block, to the left of this or to the right, we can have two contiguous period of time free. Like if you are moving this left, then it will start from 0 and end at 1. So there will be free time from 1 to 3. If we move this to the right, like it will start from 2 and end at 3. So we can have the free time from 0 to 2. So here the answer would be 2. So it is best to move this block to one unit left or right to have the maximum free time. Uh, in the third example, event time is 10 and K is 1, so we are allowed to move one meetings and three blocks. So there is a meeting from 0 to 1, 2 to 4, and 9 to 10. The best solution here would be to move these blocks. Like if we move this block to the left of this or to the right, most like till this, ending at this, then we can have like if we move this to left, so 0, 1, and from 1 it would be up to 3. So 3 to 9, it will be the free time. So we have 9 minus 3, 6, the answer. Other moving any other like moving this block to here, it will be 10 minus 5, which is 5. So it will be lesser only. The maximum we have is 6 here. In example 3, event time 5k equals to 2, and here all meetings are continuous like 0 to 1, then 1 to 2, 2 to 3, 3 to 4, 4 to 5. So we can't have any, even though can't move at all, and event time is also equals to the total meetings duration. So answer is 0 here. So this was the whole the problem. So uh, deriving solution, we have to like first understand the requirement flow. Suppose there is an event happening from 0 to t here, and suppose there are three blocks. Like this is B1, so this is starting at S1 and ending at P1 time. There is block P2. Block we can name it M1, like meeting 1, and M2 meeting 2. S2 E2, there is a meeting here S3 E3. Uh, M3, like meeting 3. Okay. Suppose like K we have is 0. This means we can't move any of the meeting. So the maximum answer we can have is like maximum of these 3 times. Like out of these 4, we can have, we will find the maximum one and we'll return that value. So if we are not allowed to move anything, then this will be the maximum. Suppose K is 1. In that case, we can move blocks either to the left or to the right. So we can move this block to its left, like it would start from 0, like S1 and E1. Then the answer could be this 3 block, this block, or this block. Similarly, we can do same for M2. Like yeah, similarly, we can move M2. So we can move M2 just after M1. Like it could start from here. Then the answer could be this block or this block or this block. Similarly, we can do for M3. It should be moved immediately till M2, and then the answer would be this block, or this block. So it kind of intuitive till now. The main thing comes when k is more than 1. So if suppose k is 2, here the best way, like best solution would be like to move blocks together, like meetings together. So if we move M1 and M3 and we are keeping M2 as it is, so this won't increase the free time that we have. Like it won't combine the free times of before and after of M1 and before and after M3 to give some value for maximum value. So this would be blocking that. So the best answer would be to move blocks together. So if you move M1 and M2 together here, so somewhere it could start M1 here and M2 could start just after M1 and M2. So the block from here to here could be some max value. Then this. So out of this we can take whichever is maximum. So here the main thing was to move block together. Like this is the classic sliding window technique. If you don't know what this is, read and understand. Where we will first find for first two like k block, like if we'll find answer for 2 blocks. So here if I show you, the answer would be, we have total duration would be E2 minus. So to make the calculation easy, I added 2 more block in answer of, like this would be S0 and E0, here S and En. So the if k is 2, if moving these 2 blocks together, the free time will be equals to, we'll first find the total duration. So total duration would be from here to here. It would be k plus 1. Like if it is E2, it would be S3, the starting block of k plus 1 element minus the first, like before first ending time. So that is E naught. This is the total time, like S3 minus E naught means ending time of first block. So if k is 2, then this is the total time we have. We will minus it with the duration of M1 and M2. M1 and M2. Duration we can calculate easily. So this would be S3 minus E naught minus, this would be basically E1 minus S1 plus E2 minus S2. So like this is for first 2 blocks. Then we will move one point ahead, so then we will calculate M2 and M3. Then we will our total duration would be from here to here, and we will subtract the duration of M2 and M3 to get the maximum free times. So like this we can solve the problem. Let's go through the solution to understand it perfectly. So to combine the start and end time, I took vector of pair like BP and size of an array. I pushed an empty blocks to make it the calculation easy. Then I pushed an element start time in time. Then I again pushed the last element here. Answer will be holding the maximum we can have. So if as I said, we will first take the k element duration. So duration would be VPI second minus VPI of first means VPI of second is in time minus start time. So first k element I will add duration. Remaining free time would be k plus 1 start time minus uh, before 1 whatever is the block. So this is 0 block. Second means in time. So that would be the total duration, total event time. Basically, we will subtract the duration of meetings. So that remaining time would be the free time. So that we will store in answer. Now sliding window, we just move one bit ahead and ahead. So here k, I will k plus 1 to n. I will do subtract the first duration like last k duration, and I will add my current duration. And in RAM, I will remaining time I will calculate by like start time of next block I plus 1 block minus last block like last block in time. That would be my duration, total event time, which we need to subtract. Answer will be the max of all those values, remaining values. We'll return that answer. So that was all for this video. So I hope you understood it. If you have any doubt, you can ask. So there is part two of this question also. So in this next video, we'll discuss the part two. Yeah. So if you have any doubt, you can ask in the comment section. Thank you.